Welcome back. We're going to take a look at exponentials. So for the compound interest rate, we have the formula A equals P times, in parentheses, 1 plus R over N to the N T. So A is the end value of the investment, so your future investment. P is the principal or the initial balance. R is the decimal interest rate. N is the number of times compounded per year, and T is in years. So what's happening here is they're trying to account for the interest compounding. So you may not need to use this, but if you're looking at compounded interest over time, you're going to want to do it this way so that you don't have a conflict between the years and how often the interest is compounding and end up winding up with the wrong answer. The next one we have is exponential growth and decay. So y, again, is the end result, a is the initial value, r is the rate, and x is the number of intervals. For growth, I made a really simple problem for each one of them. The value of a $500 antique grows by 5% a year. So the new value of the antique is equal to $500 the initial investment times, in parentheses, 1 plus 0.05, 0.05 being the rate, and x being the years. By the way, the whole idea behind this one, when we're looking at rates, is because you need to include the principal balance. If that one wasn't there, what you'd actually be getting is just the increase. You wouldn't be getting what the total value was. You'd just be getting the increase in value. So keep that in mind if that's actually what you're looking for. Then we have decay, so the value of an old $1,000 car decays by 7% a year. The new value of the car will equal 1,000, the initial, times, in parentheses, 1 minus 0.07. Notice that we changed the sign to x. So if we're doing decay, make sure that you register what the sign should be. And, they may word it really weird. They may say that, it's at 93% of its value for the year or something, and imply that it's 7%. So something weird like that. So just keep in mind what they're actually saying and how you're going to represent that inside. Lastly, we have continuous exponential. A T is the end result, A0 is the initial value, E is Euler's constant. It's roughly 7 or 2.72, but it'll be on the calculator. So given that it's a continuously growing function, you could have some major rounding errors if you use this number like this. So actually use the number on the calculator. R is continuous rate. Note that this is not the same thing as rate in the way we're traditionally used to seeing it, like you drive miles per hour or something like that. This is happening instantaneously. So don't confuse that concept of what they're actually asking for here. And T is the time, or the intervals, depending on what we're actually looking for. You'll see this problem a lot with like population growth, especially with like bacteria or something like that. Oh, and that's the end of that.